Hello everyone, my name is Jesus Dominguez. Currently I am making my PhD on nanosciences and micro nanotechnologies at Instituto Politécnico Nacional in Mexico. Today we are presenting the results of our project named Physical Properties of Sputtered Gallium Nitride and Aluminum Nitride films deposited on silicon 111 and silicon 100 substrates. The purpose of this project is to show the benefits of using an alternative technique of growing in compared with the already established techniques such as molecular beam epitaxy and metal organic chemical vapor deposition, which have been proved and have been used as high standard techniques for high standard crystalline materials. The radio frequency sputtering growing system has demonstrated a low temperature and a low cost conditions of growing, which collocate this technique as a cheaper and an easier technique to start producing high quality semiconductor devices in the form of thin films. In compare with the DC sputtering system, the radio frequency system is alternating the polarity of the target where a magnetron is collocated, and this alternancy of the polarity is reducing the contamination, or as we know it, the poisoning of the target, where the alternancy of polarity is constantly cleaning the target surface. In these conditions, we have alternate and we have been growing thin films, modifying the target composition. First, we did it with gallium nitride powders and aluminum nitride powders from Sigma Aldrich of high quality. We deposited these powders on target holder, and we compress them until we create this solid target. Modifying this composition, first we tried with gallium nitride using argon as an inert gas to activate the plasma and to start the deposition, and then we change it for aluminum nitride powder to create a solid target, and we also use argon as an inert gas to activate the plasma. In some variations, we change this to a small target where we include a little composition of indium as an addition in order to show the modification of the band gap and the impact of the addition of indium in the target, in order to see the variation of the band gap adding indium to the gallium nitride lattice. In the results, well, we have seen and we have obtained X-ray diffraction spectrum and Raman spectrum, where unfortunately we haven't demonstrated completely the presence of gallium nitrate either on cubic Simblenda structure or the Wurtzita hexagonal structure, but the UV visible spectrum has shown that we have found remnants of the presence of a structure of the gallium nitrate. In addition to this, the results of the thin films deposited with the gallium nitrate and indium target have also demonstrated the efficiency and the impact of the presence of indium in the gallium nitrate lattice. With this project, we are planning to continue changing the composition of the targets in order to help the radio frequency sputtering system to start to deposit thin films with the proper physical and optical conditions of semiconductors of ultra wide band gap, which have potentially demonstrated the efficiency of emitting in the UV deep region close to the 200 nanometers. We really appreciate all of your comments and all of your feedback, and also all of the suggestions you may have for our project. Thank you very much for your attention.